completing the square. So we talked about parabolas. We have the standard equation of a parabola, which is x minus h equals 1 over 4p times y minus k squared. And that's for horizontal. And then we have y minus k equals 1 over 4p times x minus h squared. And that's for vertical. So if I give you the following equation, y squared plus 2y plus 12x minus 23 equals to 0. If I want to get it into standard equation, then I need to complete the square. Since we only will be completing the square on the y's, then we want to isolate the terms. So y squared plus 2y plus a number, and we want to move the other, the 12x and the negative 23 to the other side, equals to negative 12x plus 23. Now we can complete the square. So 2 divided by 2 will give us 1. Square will give us 1. So we need to add 1 to the other side. So this is going to give us y plus 1 squared equals to negative 12x plus 24. Well, this one looks like a horizontal parabola. So we want to make it, we want to get it to the point where it looks like the horizontal standard equation. So what I want to do is I want to factor out a negative 12 from the x, or from this side. So I'm going to factor out a negative 12 times x minus 2. Now I'm going to divide both sides by negative 12 and divide by negative 12. So then I have that x minus 2 equals 1 over negative 12 times y plus 1 squared. So now it looks like the horizontal, like the standard equation of the horizontal. So from here, we can find the vertex. So our vertex is at h and k. So it's going to be at 2 and negative 1. We can also find our p. So we know that 4p equals negative 12, so we divide by 4, divide by 4. P is going to be equal to negative 3. Since p is less than 0, then it's opening to the left. Now we can find the focus. So since it's a horizontal parabola, the movement is happening on the axis. So the focus will be at h plus p and k. Our h is 2, and our p was negative 3, and k was negative 1. So our point is at negative 1 and negative 1. Now we can find our directrix, and our directrix x equals h minus p. Our h is 2 and our p was negative 3, so this would make it a positive 3. So it's at x equals 5. Now we need to find the axis of symmetry. So the axis of symmetry for a horizontal is going to be at y equals k. So then y equals negative 1. If we want to find the distance of the lactus rectum, remember that it's the absolute value of 4p. 4p is negative 12. So the absolute value of negative 12 is 12. So which means that we're moving 6 units up and 6 units down from the focus. So our change is happening on the y's. So from the focus, which was at negative 1 and negative 1, now we're going to have a point at negative 1 and 5 and negative 1 and negative 7. We're adding and subtracting 6 from negative 1. So now we can graph. So our vertex is at 2 and negative 1. So it's right here. Our focus is at -1 and -1, which is right here. Our axis of symmetry passes through the focus and through the vertex. Our directrix is at x equals 5. And then we have the other points, -1 and 5. And -1 and 7, -7. And since P was less than 0, then we're opening to the left. So this is our graph. Let's do another example. So if I have x squared minus 2x minus 4y plus 9 equals to 0. Since we're only completing the square and the x's, we want to isolate those terms. So x squared minus 2x plus a number equals 2. I'm going to move my negative for y to the other side, so it's going to become positive for y. And the 9 to the other side, so it's going to become -9. So -2 divided by 2 is going to give me -1 squared. It's going to give me 1. So I add 1 to the other side. So this will become x minus 1 squared equals 4y minus 8. This is going to be vertical. So it's going to look this way. So what we want to do is we want to factor out a 4 from the y and the 8. So then this is going to give me 4 times y minus 2. Now I want to divide by 4. Divide by 4. So y minus 2 equals x minus 1 squared over 4, which is the same thing as y minus 2 equals 1 over 4 times x minus 1 squared. So from here we can find our vertex. So the vertex is going to be at h and k. So our h is 1 and our k is 2. Our p, well, we know that 4p equals to 4. So then p equals to 1. Since p is greater than 0, then it's going to open up. To find the focus, since it's a vertical hyperbola, the movement is happening on the y's. So the focus is at h and k plus p. Our h is 1, our k is 2, and our p is 1, so our point is going to be at 1 and 3. To find the directrix, since it's a vertical parabola, it's going to be at y equals k minus p. So y equals 2 minus 1, so y equals 1. To find the axis of symmetry, it's going to be at x equals h, so x equals 1. And to find the distance of the latus rectum, we know that it's at the absolute value of 4p. 4p was 4. So then that means we're moving 2 units to the left and 2 units to the right. So from the focus, which was at 1 and 3, we're adding to the x's. So it's 1 plus or minus 2 and 3, which is going to give us the points 3 and 3 and -1 and 3. Now we can graph. So then the vertex was at 1 and 2. The focus was at 1 and 3. The directrix was at y equals 1. The axis of symmetry passes through the focus and the vertex. And we have our points at 3 and 3. And the other one at -1 and 3. And since it's opening up, This is our parabola.